Greatest common factor. How can you find the GCF of a set of numbers? Keisha is putting together bags of supplies. She has 42 craft sticks and 12 glue bottles. If she puts an equal number of craft sticks and an equal number of glue bottles in each bag, what is the greatest number of bags Keisha can make so that nothing is left over? This is where GCF will come into play. First, we must list and compare all the factors of each number in the set. So for 12, the factors are 1, 2, 3, 4, 6, and 12. For 42, the factors are 1, 2, 3, 6, 7, 14, 21, and 42. When we look, 12 and 42 have factors of 1, 2, 3, and 6 that are in common. They are both in 12 and 42. These are called their common factors. But to find the greatest common factor, we want the greatest number that the two have in common. You can see that the GCF is 6 for 12 and 42. This means that the greatest number that can be divided evenly into 12 and 42 is 6. So Keisha can make 6 bags. When we look at greatest common factor, we can write a definition as the greatest number that is a factor of 2 or more numbers. That means if we look at an example here, we could have 16 and 24. The factors of 16 are 1, 2, 4, 8, and 16. And the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Although they have more than one factor in common, the greatest common factor of 16 and 24 would be 8. Oops, excuse me there, forgot to put on my pen. Now, there are different ways to find that. One method, which we've already learned, is to make a table or a list. We can list them out vertically or horizontally, whichever you prefer. So in one method, we can see that the factors of 20 are 1, 2, 4, 5, 10, and 20. We can see that the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Again, although they have more than one factor in common, the greatest common factor would be 4. We can also use our T-charts like we learned when we did prime factorization. 20, 1 times what would give me 20? I could list it as 20. 2 times 10 equals 20. 3 doesn't work, so I could just cross it out. 4 times 5 equals 20. And I'm at 5, and since I've used that already, I can cross out everything after it. Same thing for 36. 1 times 36 equals 36. 2 times 18 equals 36. 3 times 12 equals 36. 4 times 9 equals 36. 5 doesn't work, so we could cross that out. And 6 times 6 equals 36. And we're a number that I began at, so I can cross everything after it off. Again, looking at both sides of my list, I can see that 4 is the greatest common factor of 20 and 36. Another method you could use would be the rainbow factor to find the greatest common factor of 20 and 36. This is kind of the same technique, but a little bit different. I could say that I could have 1 times 20 and make the outside of my rainbow. Then 2 times 10, connecting them, and 4 times 5, making it kind of a rainbow shape. Doing the same thing with 36. I'm going to move down a little bit just for room. 1 times 36 would work. 2 times 18. 3 times 12. 4 times 9, and I'm going to run out of a little space here because I'm going to put my 6 below here, because 6 times 6 also gives me 36. There are all my factors. Again, I can see that the greatest factor they have in common is 4. So that would be the GCF of 20 and 36. One other method we could use is prime factorization to help us in making Venn diagrams. This is a little different, but still gets the same results. Cutting out 20, making my tree, I can say that 20 is 2 times 10. 2 is prime, so I'm going to circle it. Break down 10 into 2 times 5. I'm at prime numbers, so I can circle them. So 2 times 2 times 5 equals 20. Doing the same thing for 36. Again, starting with any numbers I want. I'm going to start with 2 times 18. 2 is prime, circle it. Breaking down 18 into 2 times 9. Circling the 2 as a prime number. And 9 breaks down into 3 times 3, circling those. So 2 times 2 times 3 times 3. Again, having my prime numbers. That will help me with finding out how to do a Venn diagram. Now, when I go to do my Venn diagram, we all do know what a Venn diagram looks like. We've used those many times. In the middle, we want to put what they have in common. Well, I have a 2 here and a 2 here. So I'm going to put just 1 2 in the middle. And I have another 2 in here and another 2 here. So I'm going to put another 2 in the middle. I only put 1 from the pair in the middle. I have nothing else in common. So in the middle, I can see I have 2 and a 2. Well, 2 times 2 equals 4. That is my GCF. If I multiply everything that they have in common, it gets me my GCF. Let's go ahead and give one a try. Here are some numbers that you can try. If you'd like to try, we could work on 18 and 36. I'm going to switch to a blank page. You can use your page in the book. So if I have 18 and 36, I'm going to use my prime factorization method. 18 breaks down into 2 times 9. 9 breaks down into 3 times 3. Here are my prime numbers. I'm going to circle them and write them in expanded form. 36 breaks down into 3 times 12. 12 breaks down into 3 times 4. And 4 breaks down into 2 times 2. Again, circling all my prime numbers. And I see that I have 2 times 2 times 3 times 3. If I would put that in my calculator, I'm sure that would equal 36. Now I can go ahead and draw my Venn diagram. And let's see what I have in common. Well, I have a 2 here and a 2 here, so I'm going to put 1, 2 in the middle. I have a 3 here and a 3 here, so I'm going to put a 3 in the middle. I have another 3 and another 3, so I'm going to put another 3 in the middle. Now, I can multiply those together. 2 times 3 times 3 gives me my GCF. Well, 3 times 3 is 9 times 2. That's going to equal 18. So there I can see that my greatest common factor is 18. That is just one method. You are free to use any method that you would like to try to solve the rest of the practice problems in your yellow book.